This mode verifies packages or the contents of the file system. So verifies file system contents against installed packages or package, because it's done one at a time in RPMDB. And it returns when we instruct it to test for discrepancies. Let's just note that it returns a single dot per test performed if the test has passed. So returns dot per test performed if the test pass. And if the test has failed, then a particular value is returned, and there are a number of those values. So note, if test fails, one of the following will be returned. So a number of tests are performed. If you see, for example, instead of a dot, the number 5, it means that the MD5 signature failed. If you see an S, it means that there's a discrepancy in the file size. If you see an L, there's a symlink error. If you see T, for example, there's a modification time discrepancy. If there's an uppercase D, there's a device problem, such as wrong device name, missing device. If you see an M, uppercase, there's a mode issue, which can relate to permissions or the mode of the file. If you see a question mark, RPM was unable to read the file. And if you see an uppercase U, there's a discrepancy with the user owner. And similarly, an uppercase G means there's a discrepancy with the group owner. These are the types of tests that are performed when you perform a verification on a particular package. So how does verification work? Let's show you how this would work. Supposing we wanted to verify bin grep. So we'd execute RPM, uppercase V for verification mode, and lowercase v for verbosity to print information to us. On the file, F means file, bin grep. This will compare the bin grep binary or grep binary in the bin directory against the metadata stored in the RPM database concerning that file. So let's go ahead and try this out. And now as we scroll up, all of these items are items that are contained within the grep package. For each item tested, notice all of the dots. That means, since we see none of the other values that we've mentioned, that all of the tests have passed for all of these items, which means there are no discrepancies between the file system representation and the database representation of the contents of the grep package. These items here just happen to be beneath a particular directory, which is why the directory is referenced in that particular case. It's a file within it. So how can we introduce a discrepancy to prove whether or not RPM is doing its job? Well, that's quite simple. So let's just note, compares bin grep to grep RPM. So to introduce a discrepancy, let's move, or perhaps even copy, let's move it to a new file, then create a new dummy file. So we'll move bin grep to bin grep.original. We'll restore it when we're done. And then we'll touch bin grep, which will create a 0-byte file, which will certainly cause a discrepancy. And any process that relies upon grep will fail for that particular point, so don't do this on a production system. Let's SU in. We need to be the root user in order to effect this change. So if this has run successfully in bin, we now have two instances of grep, a 0-byte version and the original. Now let's rerun our verification. We should just copy that, or we can just RPM verify the file, and we want verbose information on the file bin grep. Now most of the files will return well, but as we scroll up towards the top, we'll see that there are discrepancies in the file bin grep. So if we compare what we see here to the fields that we've outlined, no need to memorize them, or if you just consult the RPM documentation, you'll see what each of the values mean. But looking at this, we see, for example, that the S test failed. That means the file size of bin grep is incorrect, which means if we use DD or some other means to make the size correct, then the file size, meaning the actual size of grep, would be okay. But beyond the file size, the MD5, or in this case the mode, has failed, not the MD5. The next step is the MD5 has failed. So M, the mode, has failed. So there's a discrepancy between the mode. Now let's compare and contrast, just to be clear. And if you notice, grep original was flagged executable. This new grep is not flagged executable. So 1755, the other is 644. The MD5 has changed. Well, certainly. Let's MD5 sum bin grep star. Indeed, there's a discrepancy between the MD5 strings of these two items, as expected. And then, of course, the modification time doesn't match the RPM database. So if we stat bin grep star, we'll see that the mod times are clearly different. The modification time of bin grep is 114, and of this particular item, bin grep original, is from 2010 May. So discrepancies. So this tells us that there's a problem, and one way to work around this problem is to reinstall the grep package. That's quite possible, which would reinstate the entire configuration so that it's returned to normal. So that leads us to the next mode, install. And there are other ways to verify, by the way. You can verify packages. You can verify all of the packages on your system, which will compare everything on the system and return a report regarding whether or not there are discrepancies found. So install is another mode. Install is a mode that, of course, will install packages. It doesn't upgrade, it simply installs. So if a package does not exist already, it will place the package there. And if the package does exist, then let's take a look. We'll see what happens. Well, RPM IVH will point to grep on the remote system. Let's look for the grep package, and indeed, here's the URL. So let's copy link location and to our root shell, RPM IVH. V is verbose, H prints hash marks to indicate the status of the installation. So let's RPM IVH the following URL, grep, and it notes that it's already installed. Now let's see if it's overwritten our files by rerunning the verification on bin grep and consulting the output, scrolling towards the top. Notice that it hasn't overwritten. So the installation of a package will not occur if the package already exists. So install works if package does not exist on the system, which we'll show an example of by installing Unix to DOS. So let's get the Unix to DOS URL, and we know it's not installed because it's not installed by default, and this will be a package that's installed momentarily, and then we'll get back to fixing the grep issue. So let's clear screen, Control-Shift-V to paste, and this will install Unix to DOS. And RPM query info Unix to DOS, which is the main name, should reveal that it's now installed, which means we should be able to find Unix to DOS. That's there, which leads us to another mode. That's upgrade. Now upgrade installs and or upgrades. So if a package does not exist, it will install it, and if it does, it will upgrade it. Let's try to RPM, and this is enacted with or affected with the uppercase U option, verbose hash marks, and let's get the URL for grep, which should be on the command line somewhere, and we should be able to pull that out by going into the command history, and that's Unix to DOS. Let's change this IVH to simply UVH, which is an upgrade process. notice that it sees that the same version of the package is already installed. Let's go ahead and run the verification yet again, and this will dump quickly to stand out. And notice